This is SpaceTime, Series 28, Episode 44, for broadcast on the 11th of April, 2025. Coming up on SpaceTime, new insights in the atmosphere of Uranus, the 2025 Space Environment Report on space junk, and NASA and Boeing preparing for a new round of Starliner testing. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have uncovered new insights into the atmospheric composition and dynamics of the mysterious planet Uranus. The findings are based on 2 decades worth of observations of the ice giant by NASA's Hubble Space Telescope. Uranus is a strange world, travelling around the Sun tipped on its side, rotating at a nearly 90-degree angle from the plane of its orbit. It's the 7th planet from the Sun and the 3rd largest planet in the solar system, about 4 times the size of the Earth. Uranus is surrounded by a faint ring system and has more than 24 small moons. The new Hubble results will help astronomers better understand how the atmosphere of Uranus works and how it responds to changing sunlight. These long-term observations provide valuable data for understanding atmospheric dynamics. When Voyager 2 flew past Uranus back in 1986, it provided a close-up snapshot of the sideways world. We know that Uranus's atmosphere is mostly hydrogen and helium, with small amounts of methane and traces of water and ammonia. The methane gives Uranus its cyan colour by absorbing the red wavelengths of sunlight. What Voyager 2 saw resembled a bland blue-green billiard ball. By comparison, Hubble chronicled a 20-year story of seasonal changes between 2002 and 2022. Over that period, scientists used Hubble's spectrograph to develop an accurate picture of the atmospheric structure of the planet. They observed Uranus 4 times, in 2002, in 2012, in 2015, and again in 2022, finding that unlike conditions on the gas giants Saturn and Jupiter, methane is uniformly distributed across Uranus. Instead, it's strongly depleted near the poles. And this depletion remained relatively constant over the 2 decades. However, the planet's aerosol and haze structure changed dramatically, brightening significantly as the northern polar region of the planet approaches the northern summer solstice in 2030. Uranus takes a little over 84 Earth years to complete each orbit around the Sun. So over the 2 decades, the Hubble team have really only seen the northern spring as the Sun moves from shining directly over Uranus's equator towards shining almost directly over its north pole in 2030. The Hubble observations are suggesting complex atmospheric circulation patterns on Uranus during this period. The data that's most sensitive to methane distribution indicates a downwelling in the polar regions and an upwelling in other areas. Over the years, the authors watched the seasons of Uranus as the south polar region darkened, going into a winter shadow, while the northern polar region brightened as it began to come into a more direct view as the northern hemisphere summer approaches. At middle and lower latitudes, aerosols and methane depletion have their own latitudinal structure that mostly didn't change over the 2 decades of observations. However, in the polar regions, aerosols and methane depletion behave very differently. The aerosols near the North Pole displayed a dramatic increase, showing up as very dark during the early northern spring and turning very bright in more recent years. Aerosols also seemed to disappear as the solar radiation disappeared. And this is evidence that solar radiation is changing the aerosol haze in the atmosphere. On the other hand, methane depletion appears to stay quite high in both polar regions throughout the observing period. Needless to say, astronomers will continue to observe Uranus as the planet approaches its northern hemisphere summer. This is SpaceTime. Still to come, the European Space Agency's 2025 Space Environment Report, and NASA and Boeing prepare for a new round of testing of the troubled Starliner spacecraft. All that and more still to come on SpaceTime. The European Space Agency has released its latest Space Environment Report, warning of the ever-growing problem of space junk orbiting the Earth. Our planet is surrounded by spacecraft carrying out important work to study our changing climate, deliver global communications and navigation services, and help answer important scientific questions. The problem is some of their orbits are getting really crowded and increasingly churning with deadly fast-moving pieces of defunct satellites and rockets that threaten operational spacecraft. Since 2017, the European Space Agency's Space Debris Office has published an annual space environment report in order to provide a transparent overview of global space activities and determine just how well international debris reduction measures are working to try and improve the long-term sustainability of spaceflight. The 2025 report says intact satellites and rocket bodies are now re-entering the Earth's atmosphere on average more than 3 times a day. However, still not enough satellites are programmed to leave heavily congested orbits at the end of their lives, thereby creating an increased risk of collision. In fact, 2024 saw several major fragmentation events, as well as many smaller ones. Together, these have added thousands of new debris objects into space, underlying the need for prevention by implementing passivation and reduced orbit lifetime measures. The report says that even without any additional launches, the amount of space debris will simply keep growing. That's because of fragmentation events as spacecraft collide. That results in new debris objects building up faster than debris can naturally re-enter the atmosphere. The United States is currently tracking well over 20,000 artificial objects in orbit above the Earth. Now, of these, only about 4,000 are operational satellites, with the rest being disused spacecraft, spent rocket stages, and larger segments of space junk big enough to be tracked from the ground. And current estimates suggest that there are probably more than 200 million bits of space junk a few centimetres or less in size orbiting the Earth. Now, all these objects are travelling at orbital speeds of 28,000 kilometres an hour. One of the biggest fears are cascade events, where satellites, spent rocket stages or bits of space junk slam into each other, creating more shrapnel and space junk, which then slams into other spacecraft, creating even more space debris and so on. Ultimately, the Earth could face what's known as a Kessler Syndrome. First proposed by NASA scientist Donald Kessler back in 1978, the Kessler Syndrome involves a runaway chain reaction of collisions, exponentially increasing the amount of debris clouds orbiting the Earth to the point where the distribution of debris could render space activities and the use of satellites in specific orbital ranges impractical for generations. And it's not that far-fetched. The International Space Station is regularly forced to change orbit to avoid space junk, with crews needing to seek refuge inside docked capsules in the event of a collision, and the potential need to undertake emergency escape back to Earth. Spacewalking astronauts have also recorded impact damage to the orbiting outpost, and returning spacecraft have also shown evidence of debris impact caused while in orbit. And it's all been happening very quickly. The first major recorded satellite collision was back on February the 10th, 2009. That's when the 560-kilogram Iridium-33 telecommunications satellite collided with a deactivated 950-kilogram Russian Cosmos 2251 satellite. The collision occurred some 800 kilometers over Siberia at a relative speed of 11.7 kilometers per second. That's about 42,120 kilometers per hour, destroying both spacecraft. In January 2020, the disused Russian Cosmos 2491 spy satellite was suddenly hit by a piece of space junk, shattering it into at least 10 major fragments. But to date, the worst incident, polluting space with deadly shrapnel, wasn't an accident but deliberate. Back on January the 11th, 2007, China conducted an anti-satellite missile test using a DF-21 ballistic missile launched from the Xichang Satellite Launch Center to deliberately blow up a disused Chinese weather satellite, for no other reason than in order to demonstrate to the rest of the world that they could do it. The missile slammed head-on into the 750-kilogram Fengyun FY-1C weather satellite at an altitude of 865 kilometers, traveling at 8 kilometers per second and smashing both spacecraft into a massive debris cloud containing hundreds of thousands of bits of shrapnel. The event remains the largest recorded creation of space junk in history, with well over 2,000 pieces of trackable-sized space debris catalogued in the immediate aftermath. Beijing was condemned by other nations, including the United States, Britain, Japan, Russia and Australia, for their actions, which dramatically worsened the problem of space junk and increased the dangers it posed to both people and spacecraft. And those fears proved justified on January the 22nd, 2013, when a Russian laser ranging satellite was struck by debris from the 2007 Chinese missile test, damaging the spacecraft and changing both its orbit and spin rate. This summary of the 2025 Space Environment Report from ESA TV.
Humanity has a littering habit, from the deep sea up into the sky. Space debris is now a well-established problem. Around 70% of the 20,000 satellites ever launched remain in space today, orbiting alongside hundreds of millions of fragments left behind by collisions, explosions, and intentional destruction. And the outlook is worsening year on year. For each satellite, ESA has to perform twice as many collision avoidance maneuvers than it did 10 years ago, with some operators reporting 2 such maneuvers per month per satellite. But the challenge we face now is nothing compared to what is to come. A new era is here, the commercial space race. Access to space has become faster, easier, and cheaper, and vast constellations of satellites are dominating entire orbits on a first-come, first-served basis. Current predictions indicate that by 2030, the number of active satellites orbiting our planet could reach 100,000. Every additional satellite burns new rocket emissions, increases collision risks, and stains the skies for astronomy. Humanity's exploitation threatens a common inheritance, a common benefit, a cycle we are not unfamiliar with. International regulations and space debris mitigation measures are limited, and we are only just beginning to see the consequences of this new, complex, and unregulated mix of institutional and commercial space activity. So, is this a crisis? In some orbits, yes. Above 800 kilometers, we cannot rely on the atmosphere to pull down debris for disposal. Once these high-altitude orbits have been littered with shrapnel, there is no going back. The problem is cumulative, and, with our current level of technology, irreversible. Application-specific orbits, such as the geostationary ring, are simply irreplaceable. The satellites that enable our modern lives are at risk, from navigation for global transport to time synchronization for banking and finance, telecommunications, climate monitoring, air traffic control, and international communication. We need space now more than ever to address the climate crisis and predict extreme weather events. Sudden damage to these satellites could lead to blackouts and breakdowns with unforeseen consequences. A catastrophic chain reaction is not just a possibility, it is already underway. In some orbital regions, our behavior really could see us run out of space. Space has so much value beyond satellite services. It has been an integral part of our culture for millennia, entangled throughout our science and philosophies, our religions and mythologies. Overwhelming our skies with satellites is putting ground-based astronomy and worldwide social and cultural uses of space at risk. All future generations deserve to wonder at the night skies, just as our ancestors have before us. The stakes are high, the challenge is daunting, but there is still so much we can do to ensure a sustainable future. ESA is imposing stricter rules on itself with the goal of becoming debris neutral by 2030. The agency is reducing the maximum time that its satellites can spend in orbit after the end of their mission from 25 years to 5, and developing more reliable methods for depleting excess fuel and battery power to minimize explosion risk. ESA is also designing measures to preserve dark and quiet skies by minimizing the impact of satellites on optical, infrared, and radio astronomy. But space exploration is a global endeavor for the shared benefit of humankind. The long-term sustainability of space will require action and change from both traditional and new players. Together, the Zero Debris community is working on new principles and technologies for minimizing the creation of new space debris and improving our ability to track, monitor, and avoid the debris already in orbit. ESA is also working to establish the concept of an orbital capacity. This would evaluate the space debris generation risk associated with new and existing missions to help guide safe and sustainable operations now and in the future. Ultimately, ESA aims to treat Earth's orbital environment like an international nature reserve. What you bring in with you, you must take out when you are done, and to encourage others to do the same. In the orbits where a chain reaction of collisions and breakups has already begun, active debris removal will be essential. To prepare for this, ESA will begin to equip missions with systems to assist their removal if they are unable to remove themselves from orbit. True sustainability is complex. and rushed solutions risk creating the problem of burden shifting. Solving one problem can sometimes create another. For example, the metals and chemicals used in satellites are released during re-entry, and the impact that they have on the environment is an accelerating area of research. For objects that reach the ground, the current best practice is to let them pollute the ocean to avoid human casualty risk. So how can our use of space ever be sustainable? Space is currently a linear economy, one that starts with the construction of rockets and satellites and ends with debris. The ultimate solution would be the creation of a sustainable circular economy in orbit. To achieve this, solutions such as in-orbit servicing, refueling or reusing existing satellite platforms, or more ambitious and futuristic solutions such as orbiting recycling stations, will be necessary if humankind wishes to establish itself in Earth orbit, or even at the Moon, Mars and beyond for centuries to come. This is our chance to build healthy practices in space. Our time to act already came, and now the clock is ticking. Our world could look vastly different if our measure of success was maintaining a healthy, balanced relationship with an environment. Pollution isn't inevitable, but the choices we make today will determine access to resources for generations to come. Let's build good habits on and around the pale blue dot that future generations can be proud of. Habits that humankind can carry with it out into the solar system.
This is SpaceTime. Still to come, NASA and Boeing prepare for a new round of Starliner testing, and later in the science report, a new study found that places with high concentrations of microplastics have populations with higher rates of hypertension, diabetes and stroke. All that and more still to come on SpaceTime. NASA and Boeing are working on new tests and evaluations towards finally ironing out the ongoing problems with Boeing's CST-100 Starliner following a string of disastrous test flight attempts in recent years. The joint teams are working to resolve Starliner's in-flight anomalies and preparing for new propulsion system testing ahead of more flight certification tests in the future. NASA's Space Operations Administrator Ken Bowersox says the agency's investment in commercial crew transportation capabilities is crucial to providing the needed flexibility to operate in space as safely as possible and respond to changes quickly when they arise. Starliner's first manned spaceflight returned to Earth safely in September but without its crew, following ongoing problems with both its propulsion system and repeated helium leaks. The crew were left aboard the International Space Station. They eventually returned to Earth last month aboard a SpaceX Dragon capsule instead. For NASA, it was the last straw in the long list of failures for Starliner. It followed two earlier unmanned Starliner test flights. First, in December 2019, was plagued with computer problems. That saw Starliner enter orbit too early, unable to reach its intended target, the International Space Station. And just prior to its deorbit and return to Earth, mission managers discovered another computer problem. This one far more serious, as it would have caused the capsule and its service module to collide during their planned separation prior to re-entry, which would have resulted in the destruction of both vehicles. And once on the ground, another problem was discovered, which would have prevented Starliner from docking with the space station anyway, had it been able to reach it. A complete re-evaluation of the Starliner spacecraft and its systems was undertaken. That resulted in over 155 changes being ordered by NASA. A second test flight, slated for November 2020, was cancelled due to more software issues and the discovery of corrosion damage to 13 propulsion system valves, resulting in the need to undertake a complete rebuild of the spacecraft, including the development of a new service module. Apparently, the valves had been corroded by the intrusion of moisture, which interacted with the propellant. Trouble is, the source of the moisture was never found. A second unmanned orbital Starliner test flight finally launched in May 2022. However, two orbital maneuvering and attitude control system thrusters failed during the orbital insertion burn. That forced mission managers to compensate using the remaining thrusters with the addition of the reaction control system thrusters. But a couple of reaction control system thrusters used to maneuver Starliner also failed due to low chamber pressure during the docking procedure to the space station. And mission managers found some thermal systems used to cool the spacecraft showed extra cold temperatures, requiring engineers to manage it during the docking. Eventually, the spacecraft did return safely to Earth, landing back at the White Sands Missile Range in New Mexico 6 days later without incident. But once back on the ground, more problems were detected, this time with the harness straps on the parachute system, which required extra strengthening, and also with the glue used on the insulation of the spacecraft's electrical wiring harnesses. It turns out that glue was flammable. That resulted in another complete rebuild. And all that pushed the first manned test flight of Starliner to June 2024. But what was to be an 8-day flight to the International Space Station turned out to be a 9-month stay. As Starliner arrived at the space station, 5 of its 28 reaction control system thrusters malfunctioned. It was clear evidence that underlying issues remained with the spacecraft. Mission managers eventually got 4 of the 5 problematic thrusters operational before clearing Starliner to approach and dock with the orbiting outpost on its second docking attempt. Eventually, NASA decided Starliner simply wasn't safe enough for manned flight, and the crew were ordered to remain on station, leaving Starliner to return to Earth empty. In the months following its return, NASA and Boeing have been working on post-flight data analysis of its crewed flight test. The major in-flight propulsion system anomalies Starliner has been experiencing in orbit are expected to remain open pending further ground tests and system upgrades. Testing at White Sands will include integrated firing of key Starliner thrusters, a test of the spacecraft's thermal protection system upgrades, operational solutions for future spaceflight issues, and the testing of new helium system seals in order to mitigate the risk of future leaks. Only once they get through all these planned test campaigns will they have a better idea of exactly how fit the spacecraft is to fly again. And only then will NASA determine where Starliner best fits in the schedule for the International Space Station and its crew and cargo missions. Now that could be towards the end of this year, but more likely early 2026. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that places with high concentrations of microplastics also have populations with higher rates of hypertension, diabetes, stroke, and other non-communicable diseases. The findings, presented at the American College of Cardiology's annual scientific sessions, looked at the concentrations of microplastics in water bodies around the coasts and lakeshores in the United States between 2015 and 2019. The authors then used statistical analyses of rates of conditions like high blood pressure, diabetes, stroke, and cancer in those areas, as well as other social and environmental factors, including median household incomes, employment rates, and particulate matter air pollution in the same areas. They found that higher microplastic concentrations were associated with higher blood pressure, higher diabetes rates, and higher stroke rates, but not with higher cancer rates. A new study has shown that people who are usually being constantly distracted by their cell phones are just as likely to find other ways to procrastinate if their phones aren't nearby. A report in the journal Frontiers of Computer Science asked 22 people to work for 2 days in a private soundproofed room. They were asked to either place their phones on their desk or on another desk just out of reach. The authors found that participants didn't spend any less time pursuing leisure activities when their phones were further away. They wound up still switching between work and leisure tasks just as often. Scientists have turned a woman's thoughts into speech using a device trained on her brain activity that can speak in real time. The researchers implanted their device into a 47-year-old woman who had been unable to speak for 18 years, and they trained their device on her brain activity as she internally spoke sentences containing just over 1,000 unique words. The voice of the device was also trained using a clip of the woman speaking before her injury in order to help her voice sound like her. A report in the journal Nature Neuroscience says, while similar devices have been designed previously, this new technology is the first to allow real-time conversation and avoid delays. Neuro-linguistic programming, or NLP, is a collection of psychological and communication strategies that can be applied to help someone reach a desired goal. Classic NLP techniques, which have been around since the 1970s, include things like using visualization to change thought processes and habits, mirroring body languages to make connections with other people, and using affirmations or incantations to try and turn your aspirations into reality, such as "I think, therefore I can." While neuro-linguistic programming is considered a pseudoscience, it nevertheless remains popular among some business coaches, sales and marketing executives, and athletes. And while some people might find it useful, although probably not for the reasons they think, it's also being used by other people who have turned it into a commercial cult. Tim Mendham from Australian Skeptics says amid the psychological coaching are some disreputable groups who are offering promises of big money and certificate training.
Neurolinguistics is a psychology treatment process that is claiming to have some scientific background, that it's designed to help you cope with your particular issues that you have. Everything from confidence depression through to postpartum depression and all sorts of different things. And it's not regarded highly in scientific terms. It's not regarded as being very well founded, even though there are organisations and people with qualifications you would hope would sort of indicate that they'd be a bit more critical. Neuro-linguistic programming, NLP, is supposedly applied individually. So each person's individual circumstances means you work out the treatment you're going to give them through this confidence building, helping you sort out your deep traumas, etc. What is happening is that the industry is being taken over by some people who, because of the reliance that people who go see an NLP practitioner have for the practitioner, it becomes a bit cultish. And people are encouraged to come back and back and back for more treatment, more courses, increasingly expensive, etc., things that they can't afford. And then in some cases, they're actually saying that they're training up this person to become their own NLP practitioner. So it's one pseudoscience, largely, creating other people to follow them to promote pseudoscience.
It's almost like a pyramid scheme when you think about it.
It is a bit like pyramid scheme. It's a bit like multi-level marketing, it's called, which is basically I sell my courses to you, you on-sell those courses to everyone else, and it's a pyramid, right? People see cult aspects to this training, this NLP treatment processes. The more you get involved, the more you need to be involved, and the more you need to be involved, the more courses you are sold on, and you can do a 10-week course to help you out with these particular problems. And then, oh, by the way, we've discovered these things, so happy to go to the second level course or the premier course or the gold level course or this sort of thing. And once you're in, you're trapped and you're pouring out tens of thousands of dollars to a practitioner. And then you reach the end stage and say, what about being a practitioner yourself? And then you're going out the other end to inflict that practice on somebody else. In some instances, a well-intentioned way to treat people with depression, etc., with psychological issues. But it's like any of these things, it's vague and it can be manipulated by other people.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.